Welcome to the Flexible Curricula channel, your one-stop for anything education with your host, Nate Berman. Though we normally consult for schools and districts, we also strive to help parents who really want to be in the know for their kids' education. If you like what you see, please give us a thumbs up, share, and leave a comment. If you want to see more of our videos, hit that subscribe button. Now for today's video, we're going to be talking about the religious dogma in science and how to take that out of science. Now let's take a step back first in terms of how scientific theory comes about. There are really four parts to scientific theory. The first is what we learn about in theory, I should say, that we should be learning in elementary school. That's direct evidence. So for example, you boil some water up at 100 degrees. Okay, that's good. Can you do it again? Can you do it somewhere else? Can somebody else do that as well? Somewhere else. This is direct evidence. If it's different, then why is it different? What amendments have to be made to such a statement to actually get direct evidence? Not everything is so easy in science to get direct evidence, but that is the most definitive type of evidence we have. And there's no ambiguity about that. Everyone can agree that that evidence holds true. The next level away from direct evidence is what we call interpolation. And we can think about this in economic terms, for example. The housing market in the United States from the 50s, 60s, 70s, 80s was going up, 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 even into the 90s. But if we don't see what the values were, if we took the value of, let's say, a house anywhere in the United States, and we took its value at 1950, 1960, 1970, 1980, 1990, even January 1st, 2000, it would show that it keeps going up. And then if we took it at 2020, it would see that it's going up. But what about 2010? How was the value of 2010 compared to that? By interpolation, we'd say, okay, we connect the dots on a graph, and if it's all going up, it should fit right there at 2010 and everything would be great. But many of us remember the housing bubble. Real estate values depreciated huge amounts. Some places it was half the value or less of what it was originally worth just a short time before. So it didn't continue to go up in the direction we thought, but based on interpolation, we say, oh, well, this trend has to be. Do we know for sure that, and just like the stock market, it goes up and down, it fluctuates, although it goes, in general, it's gone in an upward trend. Do we know for sure that it's going to always do that? Oh, some days it goes down, some days it goes up. Even within a day, it goes up and down. So, but just to say the generalization that it's always going up isn't exactly guaranteed. And so there is potential for errors by interpolation. The next level away from direct evidence from interpolation is extrapolation. That's to say, well, it's going on this trend. We don't know how it's going to end, but we just say it's going to continue going the way it's going. This, many people might say, hey, this makes sense. And in theory, it makes sense. But in actuality, does it hold true? Most of the time, yes, you could say so. But is it guaranteed? No. And what if you are doing the research on the one time that is the exception, or the 10% of the times that are the exception? Well, guess what? Now you have flawed data. And if nobody else is able to get that information, direct evidence-wise, then guess what? You are now setting up a flawed theory. And this creates even more of a problem. And the last level of theory in science is the one of pure theory, where you don't have any direct evidence whatsoever. It's all potentially circumstantial evidence, much like atomic theory. We don't actually see atoms or electrons. We actually have a general idea in terms of how they behave from circumstantial evidence that gives us an implication, an indication of what is really happening, but we don't see it ourselves. There's no direct evidence to say, I see an electron, I see the atom, I know exactly how it's behaving through this whole period of time. And this is something that is part of science. And for any theory that we have through all the big theories in science, it takes pieces of these four components and piles it all together into a theory. However, the further you are in percentage wise away from direct evidence or interpolation and you move more towards extrapolation and theory, the higher potential for being flawed. Now you might say, well, scientists are pretty good, they've got to have everything right. Well, there's not necessarily. And a lot of times you're dealing with ego as opposed to, which becomes much like science become religious dogma, as opposed to being a field of inquiry. When I have taught my students year after year for science, I've explained that science is a way to explain the world with the best information we have at the time. Now, granted, what happened as we know it today might not be the same information that we know 5 years from now. A new discovery could come along, and we have a very different perspective of what's going on. So, to be able to make sure that we know this, we have to have a bit of humility when we address science as not the be all and end all, but a way of explaining it as best we can now. That may change in it having a recognition that this may be the case. One such example that I can give is where ego has to be removed from science, dealt with maternal mortality rates. A lot of new mothers were dying, and this was specifically raging through England in the 1800s, 1800s. You were seeing a huge spike of of mother mortality rates shortly after birth. And the reason why it was a spike then is because took a little while to coalesce to gather this information on a national level. But they were seeing that there was a huge spike. And why was there such mortality rates? Well, the first person who had the idea that the doctors might be the cause was a, a military doctor by the name of Dr. Alexander Gordon. And he proposed the idea, and the leaders in the hospital where he was working at that point said, "Get out of here, go back to into onto your naval ship, and deal with stuff there. Stay out of our area." That was the 1790. In the mid 1800s, there was a gentleman by the name of Ignis Semmelweis. Now, he just was not a physician. He just decided to go in and observe the hospitals and the midwives in the rooms that they were actually going and doing the delivery. And he observed everything, taking note of everything and trying to figure out what similarities were, what differences were, why did some new mothers get infection and pass away, and why did others stay completely healthy. And he did lots of observations, and he came to the idea that, hmm, these doctors are performing autopsies in the morning and of autopsies on mothers who have died from these infections, and then they go to the birthing rooms to actually help these mothers give birth, or these women give birth. Guess what happened? These women got the infection. He said this must be the cause and effect that caused it, but the medical society at that time said, no, how dare you actually declare us the cause. And they ended up putting him in an asylum, a mental asylum. Said he was crazy. Though his sound evidence was based on fact. The ego of the individuals running the society at that point eliminated the opportunity for proper scientific thought and reasoning, even though there was direct evidence to the contrary of their theory. Later on, with the advent of penicillin, and as well as understanding that there might be some other issues involved that you couldn't see, Dr. Oliver Wendell Holmes in the late 1800s had proposed something similar, and then shortly thereafter, they realized that yes, sterilization and washing your hands was a helpful means of preventing these new mothers from getting this infection and dying. But it could have been solved many years earlier had people taken their ego to the side and been willing to listen to pure direct evidence. So when we talk about religious dogma out of science, we're really saying you have to put your ego aside, look at the data. Look at the data. Now realize some data you might be making a bit of a conjecture with, like interpolation, reading in between two data points you have, or extrapolation. We have this information, what happens from here. But at least recognizing the data and your own humility and that you might not have all the answers. Science can change because we gather new information later on. Having that healthy recognition and healthy set of a level of humility is what allows true science to go forward. Please make sure that your science teachers understand this, science professors recognize this, as well as parents. Make sure that you recognize this for your own judgment in terms of understanding and taking in science information and scientific information when it comes to you, nicely packaged by beautiful headlines. Thank you for watching the Flexible Curricula channel. Once again, if you like what you see, please give us a thumbs up and share. If you know an area of science where ego is getting in the way of true science, please let us know in the comments below. If you want to know more of our videos, what they are, and to see them, hit that subscribe button. Please feel free to contact me, Nate B, at flexiblecurricula.com if your school or district would like some guidance in growing your students towards academic excellence. Thank you.